Hello, everybody, and thank you for joining me today. It's Allan Laboucan with the Rocks and Stocks News website. Today we have a very exciting project and company run by Tim Marsh. Bell Copper is looking in Arizona for a porphyry copper system. And they've been at it for a long time, but it's starting to pay off their determination. Recently, their stock has pretty much doubled from when I started covering them. And I think that they're still in the very early stages of unlocking their porphyry system. So far, it looks like they're kind of hitting the icing on the cake of a porphyry system. They're into the supergene zone. And that's what we're going to talk about today. Tim, thank you very much for joining me.
That's a pleasure to be able to do it.
So, well, let's get right into it, Tim. I would like you to sort of explain this system and how you're kind of looking for porphyry. And it looks like you've now tagged into the icing on the cake, if you will.
Right. We went off looking for a porphyry based on the idea that a porphyry system that's exposed in the roots of the Wallapai Mountains is just the bottom of a productive system, with faulting about 15 to 20 million years ago, having lopped the top off and transported the top out into the valley bottom, where it now sits underneath gravel. Once we had that idea, we went out looking in the gravel and began to find evidence of copper leaking out of the gravel, coming up through faults in the gravel. And so that told us there was a copper source down there that corresponded to the target we thought ought to be there. And so we staked claims over the area. We ran magnetotellurics, found a large electrical conductor a couple of kilometers on a side, and started drilling. We found strong evidence of a porphyry copper system in our first hole that had the identical age as the bottom back in the footwall. We dated that with uranium lead zircon dating and saw molybdenite, chalcopyrite, some little bit of supergene chalcocite in our first hole. We moved over a mile to our second hole, tested the edge of the MT anomaly. That wasn't quite a duster, but showed some chalcopyrite, some fringy propylitic alteration. And then with our third hole, we just angled the thing straight into the middle of the magnetotelluric anomaly, and at 3,900 feet drilled into a porphyry system that nobody had ever seen before. A great hematitic leached capping, very strong sericitic alteration, pretty good quartz veins. The rock texture is just obliterated by the sericitic alteration. And the hematite said, oh, there ought to be some supergene chalcocite down underneath this. So we kept the hole going, and about 40 to 50 feet, so about 300 feet of leached capping, 100 meters plus or minus, got into supergene chalcocite. We could see it replacing pyrite grains, just speckling the rock with chalcocite, forming rims on primary pyrite. And we drilled through a couple of 100 meters where we could see the chalcocite in the core. That is split and in the lab now. We see kind of high grade fractures filled with chalcocite, and then a lot of kind of intervening rock that hasn't been hit with the chalcocite very hard, but you can see it as dust out in the ground mass of the altered porphyry. Once we got down under the supergene, it was clear we're not in the copper shell. We're in the pyrite sericite zone, the QSP zone, the pyrite halo. There's a lot of ways to refer to it, but we're not drilling the primary source of that copper that we saw in the supergene blanket. What that tells me is that nature in the weathering process oxidized the primary and allowed it to kind of flatten out, pancake out over the edge of the sericitic zone. And so the hole continues with the intent of finding that primary mineralization, the primary copper mineralization. We really haven't found where our supergene chalcocite blanket came from yet. And the ideal hole, which isn't the one I'm drilling right now, will be the one that penetrates that supergene enrichment blanket directly over the primary copper. So I'm working on permitting that site right now. It'll take me a month or two to get that done, but in the meantime, I'm going to find out where the primary copper sits and what kind of grade it has.
Okay, so not all of my audience are geo speakers, Tim, and if you could maybe turn it into a bit of layman investor talk to talk about a little bit about this layering and how you expect this to the cake to be formed and what you would expect in the different layers.
Right. What we saw going down through the gravel forms a nice layer cake stratigraphy, and we ran some orientation tests as we went down. We saw that's tilted at 45 degrees back to the west. That's right. Yeah, a little steeper than that even.
Oh, wow.
About like that, about 45 degrees. So we were drilling an angle hole through a tilted tilted layering, and the first.
So the cake is kind of sitting like this, if you will.
Exactly right. The cake is tilted.
And you're down here.
Yeah.
Okay.
And so I describe it as I make the analogy of a guy with a sombrero on his head, and he's taking a snooze. So the hat's tilted. It's got a very wide brim. That brim represents the supergene enrichment blanket, which extends a long ways out from his head. I really want to hit his head. That's where the primary copper is, but because of weathering, that copper has spread out into a relatively thin blanket that's tilted at 45 degrees. Our hole has gone through the brim of his hat, and I'm kind of pointed down at his right ear, and I want this hole to keep going underneath the brim of the hat and down through his ear, and the primary copper zone will be where his head is.
So, and in these zonation of grade, you would expect as you're going through that different layers of the cake, if you will?
Yeah, the layer that we're in right now is very rich in pyrite, intense sericitic alteration. It is not a strong copper bearing zone in most any system. We see a little bit of chalcopyrite, which is a good sign. We see a little bit of bornite, which is another good sign. Those are both primary copper minerals that are related to the system when it was hot. The chalcocite that we've already gone through was produced after the system was long cold, while the cold groundwater was moving through it before it got tilted and created this flat pancake of enriched copper. But again, the place I want to find is where the brim of that hat wraps over the top of the head. And that's where that good, the very best supergene enrichment will be. And by finding where the primary zone is, that's going to tell me where I need to set up over the top and, just drill this guy right down through the top of his head. Now,
Tim, if I'm getting this correct, you've kind of drilled at the deepest portion of the sombrero or cake, if you will. Or a deep portion anyways. Why did you go down there first and not closer to the surface?
Because I didn't know any of this before I drilled the hole. As I drilled the hole, I could see the orientation in the bedding. We did these orientation tests to see which way it was tilted. I thought I was going to be drilling the shortest path possible down to bedrock, and as it turned out, the layering wasn't pointed the way I thought it was. But nevertheless, I'm still drilling into the heart of the magnetotelluric anomaly.
Well, that's a nice surprise because now you can follow the rest of the sombrero and cake much closer to surface.
That's right. I'll be able to target holes to hit that enrichment blanket in the shallowest possible locations. I'm not gonna start drilling those holes. Those are a little bit risky. I want to find the middle of this thing. It's a big system, so it's a fairly sloppy search. I'm going to be searching on 500-meter centers, but I think I know where to go to drill that first big intersection.
Well, that's, if you can drill on 500-meter centers, that certainly talks to the size potential of this overall system.
Yeah, the target that I'm pursuing is about 2.5 kilometers by 2 kilometers. So you can put quite a few 500-meter center holes into that thing. We'll start to make,
Not only along strike, but then stepping out in either direction.
right.
So that speaks of a very big system. You're not looking for something small here.
Right, and our best indication of size really comes from that footwall, the root zone. The root zone is one of the biggest root zones out there. It's 5 kilometers by 6 kilometers. The rocks are pervasively altered and veined. It's clear. A lot of hydrothermal fluid flowed up through that root and into the what I hope to be the cupola in the block that we're drilling now. So we know we're drilling a very big system. We can be bold about taking large step outs. The magnetotelluric anomaly is very large. So, you know, we're going to make big step outs and really define the size of this system as quickly as possible.
You know, some of these projects, Tim, that I follow, they seem to be a bit of, you know, science projects where companies are fearful of making big step outs. It's pretty exciting to hear that you're talking about 500-meter centers.
Yeah, we get that confidence really by seeing the footwall. The footwall is a big system. We're wasting our time if we're doing 100-meter step outs from our, you know, a good intersection like the one we got going now. Moving off 100 meters just doesn't do anything for us. We're looking at a big system. We have to define this thing before somebody takes us out. And, you know, really, once we saw what was coming out of the ground, we took the step of putting in place a shareholder rights plan. We just want to make sure our shareholders get the best deal that we can possibly get for what we've found. That there aren't many of these things that have been found recently. We've got our hands around one right now, and there will be plenty of folks that would rather have it than let us have it.
And to put that into context, I saw somewhere on the internet you put out a comparison of just how big you're looking at in comparison to other world-class deposits like Escondida and some of the greatest deposits of copper in the world. And it was quite an eye-opener, because it certainly looks like you're trying to get the message out there that you're looking for something very big.
Yeah, it takes as much time and as much money to find an 18-inch gold-bearing quartz vein at 3,000 feet as it does to find a giant porphyry, if you have strong evidence where to look. You know, you could spend years of your life trying to find the next Timmins. Bell Copper has said, let's go for the biggest things out there. Let's find a deposit that will be in production 50 or 100 years from now. And that's the scale of what our two targets are. Big Sandy is one of two properties that we have. We use the same model. The same fault has displaced both of those systems. Big Sandy is yielding results. You know, we had a good idea where to go looking for it, and our third hole is, you know, returning the goods. So we know from looking at the footwall, it is comparable in size to the biggest ones out there. The Escondidas, the OU Tolgoys. It's a large system, and nobody's ever seen the top before Bell Copper drilled this third hole, and we're seeing that indeed it is copper rich in comparison to the bottom. The bottom's elevated in moly and lots of quartz veins. The top is very clearly enriched in copper, and we're gonna see just how much of that there is.
Now, your stock has moved up quite nicely since you put out this technical information well before assay results are out. And I think that's indicative of the market's understanding of these kind of systems. You're not just out there arm waving, Tim. This model you're chasing is well understood, and it looks like, you know, the market agrees that, you're onto something pretty serious here.
The world has said we got to stop using energy the way we have been. We need to switch to electricity, produce less CO2. Bell has the means for finding the new copper that the world is going to need in spades to make this energy transition. And so we're looking for the biggest things, the things that are going to produce copper for many decades into the future. And it looks like at Big Sandy, we're on to our first one.
10, 15 years ago, I read a report that was speculating on the supply needed to at that time, electric vehicles were far into the future. They were talking mainly about the emerging economies needs just to sort of get closer to the living standards of what we have in the industrialized countries. And that report speculated that, we would need to find an Escondida practically every year to meet those demands. And that was quite a bit ahead of the electric vehicle revolution. So if you combine those two sources, supply needs, demand on the supply, we just haven't found that in the industry. And it's pretty exciting that, you're looking for something in that category of what's needed.
Yeah, a lot more of them will be needed if the rest of the world can use copper at the rate that the average Canadian or American can. We got all the amenities of life, and everybody looks on the internet and they see us North Americans living high and large, and they want the same things. And Bell is really committed to looking as hard as we can, looking for the biggest things, and doing the most to help supply that copper to anybody that deserves it. I think everybody on earth deserves as much copper as I've got. Everybody deserves good, clean drinking water, refrigerated food, air conditioning on a hot day, and Bell's determined to do what we can to find that copper.
Technology, they need a computer, they need telephones, and now it looks like they're going to jump beyond the gas vehicles and move right into electric in countries like China and India, where there's a couple billion people that are now starting to want to live a similar lifestyle as we do in the industrialized countries of North America and Europe.
Yep.
So, man, your phone must be ringing off the hook these days, Tim.
Yeah, I'm getting a lot of calls, that's for sure.
Yeah, I don't want to put you on the spot by asking you about NDAs, but I got to imagine that every serious copper company out there is keeping an eye on what you're doing.
Yeah. We got those.
Pardon me?
Yeah, we got those kinds of calls with our first intersection at BS1. It's clear they're watching us. We are the thing that they need to stay in the mining business. Every day their resource gets smaller and smaller as those trucks come up out of the pits with ore in them. Somebody else has got to be supplying what's coming out of those pits if they're going to stay in business for a long time. So Bell, ultimately we will go away, but I've got to make sure our shareholders get compensated for their patience, their perseverance hanging in with Bell to give us.
You too, Tim. I watch the internet and I see the kind of comments that are out there. For you and your team have shown a lot of determination to keep chasing this prize.
Yeah, it was clear that it ought to be there. It was easy to have a strong conviction that the target was there. The geometry just required that the tops of those things were still in existence down in the bottoms of the valleys. And so that's where Bell went looking, and it's clear we're putting the theory into the core box.
And let's talk a little bit of Arizona on its own. I mean, there are some major sources of copper in the world. Most of them are in troublesome places where you can look for elephants. Arizona is elephant country for these kind of deposits, but probably could be viewed as one of the best places to look for an elephant.
Yeah, in terms of copper or pounds of copper per square kilometer, Arizona is probably more concentrated than Chile is. Chile, the largest producer of copper in the world, is stretched out over a very long volcanic belt down the Andes, and Arizona, things are more tightly clustered. So it's a very prospective place to look for new copper deposits. 80% of the state is covered with sand or gravel or post-mineral rocks, so you can't see what's underneath. If you develop techniques for thinking about what's underneath that cover, there's a lot more copper to come out of Arizona.
So you're not just looking for one elephant either. You've got a partnership with Robert Friedland's company at your other project, and you got anything to mention on that front for us, Tim?
Just that Cordoba is working hard. They've got drill turning today, and testing this other idea. They've outlined very strong magnetotelluric anomalies, 2 of them on the project, and those are being drill tested today.
And it's the same kind of idea. You said that there's the same fault and similar geological indicators.
That's right. It's exactly the same fault, the same crack that has shifted Big Sandy out where it is, where we're finding it, has also affected the root zone up at what used to be called Wheeler Wash or Soap Wash. And so we're out in the same position out in the valley at Perseverance, where Cordoba is, drilling not just an idea, but a magnetotelluric anomaly that corresponds with the idea in the same relative position as Big Sandy. So we have nothing but high expectations for success there.
So I got to imagine that the team at Cordoba, Robert Friedland's involved there, they've got to be looking at what you're doing and learning from it as well.
Yeah, I think they're encouraged by the news coming out of Big Sandy that, the things are working, the theory's panning out, and I think as a result, they have high expectations for Perseverance. Excellent.
Okay, so let's close it up here, Tim. And so you're continuing to drill. You put some core to the lab, and I think that's important for people, because in our last interview, you mentioned that you're not just going to put what you think is barren or sniffs into the lab. You are hopeful that there's going to be something there to talk about. And then while you're doing that, you're getting ready to drill one of these step outs. Do I have that correct?
That's right. I'm drilling. We've got core in the lab, and again, I've got a good eye on estimating copper grades in core. I've got an X-ray fluorescence analyzer on my hip, and so I'm confident that what's in the lab has copper in it, is significant in our search. And at the same time, I'm working on permitting a site that'll be much closer to where the drill bit currently is. It's an angle hole, an inclined hole. So I'm many hundreds of meters away from my current drill site. I need a new site up over the top of this thing so I can drill straight down into that sombrero. And that permitting is underway today. And
you're going to be going closer. You're going to follow things closer to surface.
That's right.
Right. Well, I hope it's not lost on people that, you're not doing one of these, incremental step outs. You're really going after this thing in a big way to be able to, if you've got continuous mineralization 500 meters over and 500 meters, I mean, that speaks of the size of what you're looking for. And it now looks like you're in the early stages of proving up your model.
we saw in BS1, which is 1.2 kilometers to the east of BS3, the very same texture of chalcocite rimming the pyrite grains, the similarity of the texture of this supergene copper that we saw, a little bit of it in BS1, just tells me that the scale of the system extends over, it's kilometer scale. So our 500-meter step outs, they're appropriate.
Well, I'm certainly encouraged to hear that, Tim, not only that you're chasing it closer to surface, but that you can chase it with 500-meter centers on your drilling. That really speaks to size for me, and also that you're not messing around here. You're going for gusto.
Yeah, I want to show the biggest companies in the world that what Bell is chasing is on par for what they need if they want to stay in the mining business. So we are their customer, if they want to keep mining.
Well, that is a perfect comment to end this interview on, and I'm going to close it up, Tim. And why don't you hang around and we'll have a closing chat later on after we finish.
Thanks for the opportunity, Allan.
Well, there you go, folks. Bell Copper is looking for elephant-sized, world-class copper porphyry. These systems are well understood in the market, and that's why they've, pretty much doubled their valuation before they've even announced any assay results. But even at a $50 million valuation where it's trading at right now, if they show any signs that they're looking at something like an Escondida, Tim's talking about projects that could be producing for 50 years. And it's quite encouraging that they've tagged this sort of quite deep in the system, and now they're going to start chasing it with holes 500 meters apart and get closer to surface. So, they've got very good signs that their model is playing out, and we're in the very early stages of it. So for those people that are as bullish as I am on copper, I think that we're going to be looking at $5 plus copper per pound in the near term. And I think that will be, an average price going beyond that near term. So we certainly need a lot more copper projects, and we need big ones. And Tim is looking for a big one in a place where big ones are found. So as always, my shows are for information purposes only. It's important for you to do your homework and speak with your financial advisors. But I would certainly invite you, if you're interested in being exposed to copper, to do your homework. Tim is very knowledgeable, Joe, and has a good team, and they put together a lot of good information. So go look at that information and do your homework. And I think you'll quickly realize why Tim, the market, myself, are all very bullish on what they're finding. On that note, have a great day, and we'll talk to you soon.